All right, we're going to talk about the seasons for a few minutes. 4 key days of the year. We have summer solstice right around 21st June, autumnal equinox, 21st September, winter solstice, 21st of December, and a vernal equinox, 21st of March. Remember, those days vary, especially the equinoxes range. Vernal around the 20th of March probably, autumnal right around 22nd, 23rd of September, but we use 21st just kind of as an average number. All right, what does solstice mean? Solstice means sun stop. All right, so for example, in the summer and in the winter, we stop getting less daylight, start getting more, or stop getting more daylight, start getting less. All right, and that's kind of what's going on here. Equinox means equal night. All right, that means 12 and 12. That means on those 2 days of the year, everywhere on the planet, 12 hours of daylight, 12 hours of darkness. All right, so what causes those 4 seasons? Well, first thing is because the Earth is tilted. All right, it's tilted 23.5 degrees off of vertical. It's not straight up and down. If it were straight up and down, if the Earth were straight up and down on its plane of orbit, we would basically have fall, spring seasons year round. And if it was tilted more than 23.5 degrees, we would have more extreme seasons. We'd have hotter summers and we'd have colder winters. All right, second is the fact that it does go around the sun, all right, orbits the sun. And the third is something called parallelism of the axis. The Earth's axis, if you drew a line from the South Pole through the Earth, through the North Pole and out into space, no matter where the Earth is in its orbit, it always points at Polaris. And Polaris sits right over our North Pole. All right, so it looks kind of like this. All right, we got the red zone, which is our tropic zone between the Tropic of Cancer and the Tropic of Capricorn, 23.5 north, 23.5 south. If we were to draw a line vertical, perpendicular to Earth's orbit, and then 23.5 degrees tilted away from that, that's where our axis of rotation comes from. That's where the 23.5 comes from. All right. All right, so we start at the equator at 0. We all know that the poles are 90. I think everybody pretty much knows 0 is the equator and 90 north and 90 south are the poles. And then we have a couple more key lines, key latitude lines, key parallels. 23.5 north is the Tropic of Cancer, 23.5 south is the Tropic of Capricorn, and 66.5 north is the Arctic Circle, and 66.5 south is the Antarctic Circle. Those are kind of our reference points. They come from that tilt, right? 0 to 23.5 is 23.5 away. 90 to 66.5 is 23.5 away. So that's where those numbers come from. All right, Earth orbits the sun counterclockwise as viewed from above the North Pole once every about 365.25 days. All right, remember, our calendar is 365 days long except for leap year. And every 4 years, we add a day, 366 days. And the reason is that because those quarter days have to be accounted for. We can't have a quarter of a day in our calendar. So we wait every 4 years and we just add 1 day to the calendar, and that catches up. All right. So there's our summer solstice. How do I know the summer solstice is here? Because the northern hemisphere is tipped toward the sun. So the northern hemisphere is getting summer. Southern would be getting winter. And then we move counterclockwise. Summer, 3 months later, is fall or autumn. 3 months later is winter. 3 months later is spring. The word vernal comes from a word meaning rebirth or rejuvenation, kind of. Right. So we know that right around June 21st is our summer solstice, and then we just keep going every 3 months. September 21st-ish, December 21st, and March 21st. There's our dates. Those are the dates of our 4 key days. And then the last thing you got to kind of know about this is, where would the sun be directly overhead on those 4 days? Where is it directly above? And if you were standing on that in this particular latitude, the sun would be right over your head. And if you draw a line from the sun perpendicular to the surface of the Earth, You can see that it falls right over this line right here, and we've established from the previous slide that this is the Tropic of Cancer. Okay, so on the first day of summer, the sun is going to be directly overhead at 23.5 north, Tropic of Cancer. 3 months later, the sun's direct overhead rays would fall right on this latitude here, which we know is our equator. So that's 0. The sun would be directly overhead at the equator on the equinox. We go 3 months later, look where the sun falls here. Now the sun is directly overhead here, which we established was the Tropic of Capricorn, 23.5 degrees south. And then finally, you can't see it because it's on the other side of the Earth, but if you picture this being up in front of the sun, it would hit right here on the equator again. Okay? So the sun is always overhead, somewhere between the Tropic of Cancer and the Tropic of Capricorn. It never falls outside of that to be overhead. If you live north of the Tropic of Cancer or south of the Tropic of Capricorn, the sun is never going to be directly overhead at any time during the year. You have to live in that what we call the tropics, between the tropics, in order for that to happen. Remember we said here in Verona, on the first day of summer, when the sun is highest in the sky at noon, it's still only about 70 degrees above the horizon. It doesn't reach 90, the zenith, but it does reach the zenith in between these two latitude lines right here in the tropics. Okay. Here's another picture. Notice again, here I have summer solstice on the right side. The north is tipped toward the sun. Well, here we just flopped it. Here we've got summer solstice over here. We still go counterclockwise, so this will be summer, fall, winter, spring. You can actually see where the lit side of the Earth is. It's the one that's facing the sun. Okay? Another thing to look for to know this is summer is the entire Arctic Circle, North Pole, is in daylight during summer, and the North Pole Arctic Circle area is in darkness during winter. That's how you can tell. On the equinoxes, it's half of it. Half the Arctic Circle is always in darkness or light. Okay? There's another picture yet again, showing kind of a little bit more three-dimensional. So we've got first day of summer, fall, winter, spring, and it also shows the counterclockwise rotation at the same time as it's showing the counterclockwise revolution. All right, so there's our summer solstice. There's our fall equinox, autumnal equinox. There's our winter solstice, and there's our vernal equinox. And it does that over and over and over again, year after year after year after year. It's very cyclic. All right, last here, daylight hours. Okay, if you see the Earth's axis is tilted, or excuse me, it's tilted toward the sun. Right here, the sun is over here, so this is tilted toward the sun. So this one would be representing the summer solstice. And if you look anywhere above the Arctic Circle, North Pole area, you're going to, no matter if you watch this spin, it's never going to spin out of the daylight. So we're going to get 24 hours at the North Pole, and we work our way down till we get to the equator at 12 here in Verona. Remember, we get 15 here in Verona on the first day of summer, until eventually we get down to the South Pole and we're at 0. 24 to 0 on the first day of summer. Well, on the first day of winter, it's just the opposite. Notice the North Pole is tipped away from the sun over here. It's tipped away. So now the North Pole has 0 hours, and we work its way up as we go south until we get to the equator at 12. Remember, Verona has about 9 on the first day of winter. 9 and 15 make us the 24 hours, until eventually we're at the South Pole, where we're at 24 hours again. Okay. And then finally, our equinox is easy. Notice the North and South Pole run right through the daylight, half darkness. All right. Here, this is easy. Everywhere, 12 hours. Equinox, equal light. Right? 12 hours daylight, 12 hours night.